Troubleshooting a Jandy Aqualink system with two 900,000 BTU heaters involves a systematic approach. Firstly, check the power to both heaters from the electrical panel. Ensure that the breakers or fuses are not tripped or blown. Secondly, inspect the gas connections. Confirm that the gas supply is turned on and that there are no leaks or obstructions in the gas line. Check for any loose fittings or disconnected hoses. Thirdly, examine the ignitors. The ignitors generate a spark to light the gas. Inspect the ignitors for signs of damage or corrosion and replace any faulty ignitors with new ones. Fourthly, check the flame sensors. The flame sensors detect the presence of a flame and send a signal to the control board to keep the gas flowing. Clean any dirt or debris from the flame sensors and replace any sensors that are not working properly. Fifthly, verify the control board. The control board monitors the heaters and sends commands to the various components. Check for loose connections, damaged wires, or blown fuses. If necessary, replace the control board. Sixthly, consider the temperature sensor. The temperature sensor measures the water temperature and sends a signal to the control board. If the temperature sensor is faulty, the heaters may not activate or may operate properly. Replace the temperature sensor if needed. Seventhly, check the pressure switch. The pressure switch detects water flow and prevents the heaters from operating without water. Ensure that the pressure switch is properly connected and functioning. Eighthly, reset the system. Sometimes a system reset can resolve minor glitches. Turn off the power to both heaters and the Aqualink system, wait a few minutes, and then turn the power back on. Additional tips include contacting a qualified pool technician for further assistance if troubleshooting does not resolve the issues. Keep the heaters well maintained with regular cleaning and inspections. Ensure that the pool water is balanced with the appropriate chemicals. Consider installing a surge protector to prevent damage from voltage spikes. When checking the power supply, use the multimeter to verify that the voltage reaching the heaters matches the specifications listed on the heater's nameplate. Common voltages are 120 volts, 240 volts, or 480 volts, depending on the heater model and the electrical system. If the voltage is significantly lower than the specified voltage, investigate the wiring and electrical panel for issues such as loose connections or undersized wiring. Regarding gas connections, use a gas leak detector to check for leaks around all fittings and connections. If you detect a leak, tighten the fitting or replace the faulty component. Ensure that the gas supply pressure is within the range specified by the heater manufacturer. A manometer can be used to measure the gas pressure. If the pressure is too low, contact a qualified gas technician to inspect the gas supply system. Concerning the ignitors, carefully inspect the igniter for cracks, breaks, or other damage. Use an ohmmeter to test the ignitor's resistance. If the resistance is outside the manufacturer's specified range, replace the igniter. When replacing an igniter, use the correct replacement part for the heater model. With flame sensors, use a wire brush or sandpaper to gently clean the flame sensor. Ensure that the sensor is properly positioned in the flame path. Use a multimeter to test the flame sensor's output signal when the heater is operating. The sensor should generate a small voltage or current signal when the flame is present. If the signal is weak or absent, replace the flame sensor. When examining the control board, carefully inspect the control board for any signs of damage, such as burnt components, corrosion, or loose connections. Use a multimeter to test the voltage at various points on the control board, following the manufacturer's schematic. Replace any faulty components on the control board or replace the entire control board if necessary. Regarding temperature sensors, use an ohmmeter to measure the resistance of the temperature sensor at different water temperatures. Compare the measured resistance values to the manufacturer's temperature resistance chart to verify the sensor's accuracy. If the sensor is inaccurate, replace it. When replacing a temperature sensor, ensure that it is properly installed and located in the correct position in the water flow path. Considering the pressure switch, use a multimeter to test the continuity of the pressure switch when the water pump is running. The switch should be closed, indicating that there is sufficient water flow. If the switch is open, check the water pump, filter, and plumbing for any obstructions or problems that may be reducing water flow. Ensure that the pressure switch is properly adjusted to the correct pressure setting. For system resets, after turning the power back on, observe the heater's operation closely. Check for any error codes or fault messages on the Aqualink system display. Consult the Aqualink system manual for troubleshooting information related to any error codes. If the heater still does not operate correctly after the reset, continue with further troubleshooting steps. The importance of maintaining the pool water chemistry should be emphasized. Improper water balance can cause corrosion and scaling, which can damage the heater and other pool equipment. Regularly test the water and adjust the pH, alkalinity, calcium hardness, and sanitizer levels as needed. Follow the recommendations of a pool professional or use a reliable pool water testing kit. The benefits of installing a surge protector should be reiterated. Voltage spikes can damage sensitive electronic components in the heater and Aqualink system. A surge protector can help to protect against damage from power surges caused by lightning, power outages, or other electrical disturbances. Select a surge protector that is rated for the voltage and current requirements of the heater and Aqualink system. Regular maintenance is also crucial for ensuring the long-term reliability of the heaters. Schedule regular inspections and cleaning of the heaters to prevent problems before they occur. Clean the heat exchanger, burner, and other components as needed. Inspect the wiring, connections, and gas lines for any signs of wear or damage. Replace any worn or damaged parts promptly. Keeping the area around the heaters clean and free of debris will help to prevent overheating and other problems. The Aqualink system's diagnostic capabilities can be used to monitor the performance of the heaters. The system can display error codes, temperature readings, and other information that can be helpful in troubleshooting problems. Familiarize yourself with the Aqualink system's diagnostic features and use them to monitor the heaters regularly. If you are not comfortable performing any of these troubleshooting steps, contact a qualified pool technician for assistance. A qualified technician has the knowledge, skills, and experience to diagnose and repair pool heater problems safely and effectively. Consider enrolling in a pool maintenance course to learn more about pool heater troubleshooting and maintenance. Many community colleges and vocational schools offer courses on pool maintenance. Reading the heater's owner's manual and the Aqualink system manual is essential for understanding the equipment and troubleshooting problems. The manuals contain valuable information about the equipment's operation, maintenance, and troubleshooting. Keep the manuals in a safe place and refer to them whenever you have questions or problems. Always disconnect the power to the heater before performing any maintenance or repairs. This will help to prevent electric shock. Exercise caution when working with gas lines and connections. Gas leaks can be dangerous and can cause explosions or fires. If you suspect a gas leak, evacuate the area and call a qualified gas technician. Use appropriate safety equipment, such as safety glasses and gloves, when working on the heater. Be aware of the potential hazards involved and take precautions to protect yourself. Documenting the troubleshooting steps you take and the results you obtain can be helpful for future reference. Keep a log of any problems you encounter, the steps you take to resolve them, and the results you achieve. This will help you to track the performance of the heaters and identify any recurring problems. Consider using a checklist to ensure that you have followed all of the necessary troubleshooting steps. A checklist can help you to stay organized and avoid overlooking any important steps. Obtain a copy of the heater's wiring diagram. The wiring diagram can be helpful for troubleshooting electrical problems. If you do not have a wiring diagram, you can usually obtain one from the heater manufacturer or a qualified pool technician. Understanding the basic principles of pool heater operation can be helpful for troubleshooting problems. Pool heaters typically use gas or electricity to heat the water. Gas heaters use a burner to heat the water, while electric heaters use a heating element. The heated water is then circulated through the pool. Being familiar with the different components of the heater and their functions can help you to diagnose problems more effectively. Before calling a pool technician, gather as much information as possible about the problem you are experiencing. This will help the technician to diagnose the problem more quickly and efficiently. Provide the technician with the heater model number, the Aqualink system model number, and a detailed description of the problem. Explain the troubleshooting steps you have already taken and the results you have obtained. If possible, take pictures or videos of the problem to show the technician. Remember to keep the pool area clean and free of clutter. This will help to prevent accidents and make it easier to work on the heater. Store any tools and equipment properly after use. The Aqualink system may have a built-in self-test feature. Use this feature to test the operation of the heater and other pool equipment. The self-test feature can help you to identify any problems that may be occurring. Regularly inspect the pool filter and clean or replace it as needed. A dirty filter can reduce water flow and cause the heater to overheat. Ensure that the pool pump is operating properly. A faulty pump can reduce water flow and cause the heater to overheat. Check the water level in the pool. A low water level can cause the heater to overheat. Adding water to the pool may resolve the problem. Consider installing a water softener to reduce the hardness of the water. Hard water can cause scaling and corrosion, which can damage the heater. A water softener can help to protect the heater and extend its lifespan. Consider using a pool cover to reduce heat loss from the pool. A pool cover can help to keep the water warmer and reduce the amount of energy needed to heat the pool. If you are using a gas heater, make sure that the vent is clear of obstructions. A blocked vent can cause the heater to malfunction and can also create a fire hazard. Regularly inspect the vent for any signs of damage or obstruction and clear it as needed. If you are using an electric heater, make sure that the heating element is not corroded or damaged. A corroded or damaged heating element can reduce the heater's efficiency and can also create a safety hazard. Replace the heating element if necessary. Check the wiring connections to the heater. Loose or corroded wiring connections can cause the heater to malfunction. Tighten or replace any loose or corroded wiring connections. Ensure that the heater is properly grounded. A properly grounded heater will help to prevent electric shock. Check the grounding connection to the heater and make sure that it is secure. If you are not sure how to ground the heater properly, contact a qualified electrician. Consider installing a freeze protection system. A freeze protection system will automatically turn on the heater when the temperature drops below freezing. This will help to prevent the pool and the heater from freezing, which can cause significant damage. Consult a pool professional to determine the best freeze protection system for your pool. Use a timer to control the operation of the heater. A timer can help you to save energy by turning off the heater when it is not needed. Program the timer to turn on the heater only when you are using the pool. If you are going to be away from your pool for an extended period of time, turn off the heater and disconnect the power. This will help to prevent any problems from occurring while you are away. Consider upgrading to a more energy-efficient heater. Newer heaters are often more energy efficient than older heaters, which can save you money on your energy bills. Consult a pool professional to determine the best energy-efficient heater for your pool. Properly winterizing your pool can help to protect the heater from damage during the winter months. Follow the manufacturer's instructions for winterizing your pool. If you are not sure how to winterize your pool properly, contact a pool professional. Keep records of all maintenance and repairs performed on the heater. This will help you to track the heater's performance and identify any recurring problems. Store the records in a safe place. Consider purchasing an extended warranty for the heater. An extended warranty can help to protect you from unexpected repair costs. Read the terms and conditions of the warranty carefully before purchasing it. Contact the heater manufacturer or a qualified pool technician if you have any questions or concerns about the heater. Do not attempt to repair the heater yourself if you are not qualified to do so. Improper repairs can be dangerous and can also void the warranty. Always follow the manufacturer's instructions when operating and maintaining the heater. Failure to follow the manufacturer's instructions can damage the heater and can also create a safety hazard.